In this second video in the module, we will continue looking at confidence intervals on the mean, except we are going to use Simio for this video. And so recall in the previous video we were looking at a registration desk at a healthcare clinic. So we were modeling this as a single server queuing system, and we were interested in three performance metrics: the average time in system for the first 100 patients, the maximum queue length over the first 100 patients, and the time that the 100th patient completes registration. And in the previous video we went through the development of the confidence interval, and we arrived at the representation for the approximate 100 times 1 minus alpha percent confidence interval on mu, and we went through and looked at this calculation for 10 sample observations. And so we can go through and extend these so that we have all of them. See if I can get rid of my annotations here. Oh, well, that doesn't look like it's going to be easy, so we'll just zoom in a little bit, and we will compare these values to what we get in Simio. So in order to model this in Simio, we need some additional information. In particular, we need to know the arrival pattern and the service time distribution. So our inter-arrival times are exponentially distributed with a mean of 10.5 minutes, and the service times are triangular with parameters 7, 10, and 13. So let's look at modeling this system in Simio. And so here is our basic Simio model. As we mentioned earlier, it's a single server queuing model. So we have a source, and the inter-arrival time is specified as random exponential with a mean of 10.5 minutes, and the server, the processing time, let me see if I can shrink this just a little bit and expand this. The service times are random triangular, 7, 10, and 13. So the only other condition for our model of interest here is that I set the source stopping conditions to 100 because our performance metrics are measured over the first 100 patients. So I stop the arrivals at after the 100th, and then I specify the run length as unlimited, and so Simio will simply terminate when the 100th patient has departed the system because there are no more future events. So two of our metrics, if we go back to the metrics that we want, let's go back here, see if I can get back. Here we are. The average time in system for the first 100 patients, the maximum queue length for the first 100 patients are tabulated automatically by Simio, so we don't need to do anything for those. The time that the 100th patient completes registration, however, is not. So we added an output statistic called finish time. So if we go to our model and elements, and we created an output statistic, and we simply said record time now. So we call time now is the current simulation time. Because it's defined with respect to an output statistic, it's the current simulation time at the end of a replication, which is exactly what we want. So we have the model, and we can look at our experiment, and we just have the default experiment here running for 10 replications. So we can run the values, or run the replications, and then look at the pivot grid for the values that we're particularly interested in. Note that I actually did this previously, and the values that we have in our Excel spreadsheet actually came from this simulation model. So I just ran the simulation, exported the data, and then extracted the information that we want, as we'll see here in just a second. So the first thing I'm going to do is use the filter function in our pivot grid so I can get the exact values that I want. And I need to look at the model entity, and the server. Those are the object types I want. The model has our user-defined statistic, model entity has my time in system, and server has my input buffer. And for my data source, I need to use the population for my entity data, the input buffer for my maximum number in queue, and then my finish time, which is my user-defined statistics. And then I'll filter on data item, and I need the number in station for the number in queue. I need the time in system, and then I need my output value for our user-defined statistics. And then finally, I want the particular statistic. I don't need my minimum hours, and I don't need my maximum hours. And what I'm left with then, oops, my number in station, I don't need the maximum or the average. I'm sorry, I want the maximum. I don't need the minimum, and I don't need the average. Where's my average? There we go, average right there. And so now we can see we have the specific three metrics that we want. So the number in station for the input buffer for server 1. This is the maximum number in queue, and we can see that that average is 7.5. When we look at model entity, population, time, and system, the average is 0.5761. And finally, for the finish time, the average is 18.7593. And if we go back to our Excel sheet, we can see that these are in fact the same numbers that we got here. So we have our average value of 0.576, 7.5, and 18.79. Also note that Simio tracks the same half-width of the confidence interval, and so here's our confidence interval half-width reported by Simio, and so these are in fact the same values subject to rounding that we got when we did our manual calculation. And so Simio tracks these things for us across replications automatically. Now, what we mentioned earlier was that we could make the confidence interval half-width smaller by simply increasing the number of replications. And so let's look at doing that. So I can simply go back to my design, and instead of 10 replications, let's run 50 replications. Run. Simio picks up where it left off and runs our additional 40 replications. And now when we go back to our pivot grid, if we compare the half-widths that we have now with our previous half-width from our Excel sheet, we can see that we've gone from 0.167 to 0.0914, from 1.51 to 1.06, oops, and then finally from 0.81 to 0.31. So we've reduced the half-width of all of these confidence intervals, and so that tells us that we're more confident about our estimates of the mean. Also note that as expected, the mean estimates that we got did in fact change. So we went from 0.576 to 0.764, from 7.5 to 9.86, and from 18.75 to 18.23. So two of these changed fairly substantially, and one changed just a little bit. We could also go back if we want to be even more confident, and let's say we're going to run 100 replications. And when we increase the run length again, we will see that the confidence interval half-width has shrunk again, and now we have again three new estimates of our mean value. And we could continue this process, increasing the number of replications, and we would see that the confidence interval half-width continues to shrink. In fact, we can make it arbitrarily small by running additional replications. So in conclusion, let's look back at what we did here. So we are trying to estimate the mean value of these three random variables, and so we sampled observations from the underlying distribution, and our sampling process was to run the simulation. So we ran the simulation for n number of replications, and then we used the sample mean as a point estimate of our parameter mu, and we then developed and used the confidence interval as a interval estimate. So what we end up with is a point estimate and an interval estimate, where we can make the interval estimate is arbitrarily small by running additional replications. And so from an experimentation standpoint, we would use that confidence interval half-width to determine at what point we've run sufficient replications to be confident about the estimate of the true mean.